Hi, I'm Joe Hupcey, and I'm here with my colleague, Frank Schirrmeister. He was on a panel at DVCon 2012 entitled Build or Buy, Which is the Best Practice for Hardware-Assisted Verification? Frank, first maybe introduce yourself a little bit, then we'll recount the panel.
Okay. My name is Frank Schirrmeister. I'm responsible here at Cadence for the product management of the System Development Suite, which is this continuum of engines from transaction-level simulation through RTL simulation, through emulation, acceleration, and FPGA-based prototyping.
Great. Now, looking back at the panel, what really sticks in your mind?
Well, what sticks in my mind is, first of all, it was an interesting set of participants. We had, besides us, we had an IP provider with ARM doing leading-edge designs for performance characteristics for processors. We had a system integrator at a SoC level, Qualcomm, who's pushing the envelope towards high-complexity chips, which we love and use in our cell phones and media devices. Then we had Xilinx as a provider of prototyping capability, which goes into some of the FPGA prototypes, and also new frontiers there. They were bringing up the Zinc platform, for which we have worked together with them on a virtual platform. And then last not least, I was sitting next to Springsoft, who also provides debug tools and prototyping capabilities to their users who want to build things themselves more.
Indeed, a great diversity on the panel. It just brought up very interesting views. Now, I have to confess my bias. I'm an FPGA design and verification guy. So actually, when I look at the solutions, the commercially available solutions today, I'm amazed at what's available. And it seems like that would skew the choice to more of the buy decision versus the make.
That's right. I think from our perspective, it's definitely a buy decision. It is there's so many things designers have to worry about getting the design up and running, the complexity of the hardware itself, the interaction with the software. Why really would you want to bring in an additional risk and an additional insecurity in your project schedule by building something you can buy off the shelf yourself? But kind of connected to your first question, one of the things which stuck out in the panel is really that there is no one-fits-all solution. So I was pointing in our description to this continuum of engines, starting very early with software development when you don't have all the RTL yet. Then at one point you need to do the hardware verification. That's where RTL simulation comes in. Then you need more software again. That's emulation, acceleration. Then you need it really fast again. That's when you switch to FPGA prototyping. So it's very important to use the right technology at the right point during the design for the right task. So there's really no one-fits-all. And then going back to your question on is it futile to make, it was interesting to see ARM was giving an example where they were talking about specific requirements for their processors. There was something about memory and the commercial systems not big enough for their needs. If you have a situation like that, you want to build that, but they also admitted essentially to a fairly large team internally to build this, and they have obviously the experience to do it. Yeah. So if you have a specific need like that, then it makes sense, but for kind of the mainstream users, it's probably a skew towards the buy decision.
So regardless if you're a mainstream user, you've done this for years, or you're coming fresh to this domain, what do you think is like the number one thing for these projects to make sure you set up correctly?
Well, you want to plan ahead, right? So you need to set up the plan in a way that you use at the right time in the project the right technology. So you also want to deal with a vendor who has the ability to follow you and go with you through the different phases. So as pointed out in the panel, the interfaces between the engines become very important. Standards like Scheme, which we support, become important. And then this whole ability to move the design through the different engines, take it from TLM to RTL simulation, to emulation, to acceleration, then emulation, and then at the end to FPGA prototyping. It's very important to have a seamless flow.
Yeah. So with each phase change, you need to make sure the tool chain can support that basically, right?
Exactly. And one of the things which stuck out, Qualcomm was giving a good example there. They were talking about the 6 to 9 months they have really before they tape out the chip to get the hardware and the software together, right? They were basically saying, well, every day, every week, it takes them to get the design stable within the prototyping environment counts because they can find more bugs, can get it cleaner. So dealing with somebody, dealing with a partner who helps you guide through this flow and where the engines are actually connected is very important. Concrete examples, things which we do, for example, the rapid prototyping and the emulation piece are using the same front end. That makes it easier for users. Between RTL simulation and the acceleration piece, you can actually hot swap the emulation and the RTL simulation. And you can also connect through Scheme and our accelerated VIP, you can connect the TLM pieces into the hardware-based execution. So there's still lots of more work to be done to make the flow really seamless, connected, and kind of a no-brainer. But we have gone long strides over the last couple of years to make this flow much more consistent and easy for the user.
Very good. Well, thanks for recounting the panel and your insights.
Thank you.